So the problem for this video is to find the area of this triangle here. And of course we know the formula for the area, or one of the formulas, is 1/2 the base multiplied by the altitude or the height. There's also another formula called Heron's formula. If you know all three sides of the triangle, you can find the area. But here basically we have the triangle. We have one angle of 45 degrees, and then the two sides that contain that angle are given, 2 and 4. So we don't have a given altitude, but if we drop an altitude from this vertex here, so let's say, and again, pause the video, you're going to try it on your own. That's your first hint to draw the perpendicular there, which will be a altitude or the height. Try it, and I'll be back. Okay, so here we go. I'm going to call this altitude here H. So I form a right triangle here with sides 2 and 4 given, and then the altitude forms the third side. So just from basic trigonometry, we know that the sine of 45 degrees is equal to the opposite over the hypotenuse. Of course, the opposite side is the altitude h. So sine of 45 is equal to h over 2. And if I multiply both sides of this equation by 2, this tells me that h is equal to twice the sine. (45 degrees). So we want an approximation. We can just compute the sine of 45 degrees to be radical 2 over 2. So h would be radical 2. Let's suppose we want to give an approximate answer to this. Say the area is equal to 1/2 the base, which is 4. In this case, this side is 4, the base of the given triangle, and the times the altitude. But the altitude is 2 sine 45, so let's put a 2 here, times 2 sine 45 degrees. Now we can compute this out to get an approximation. So this will be 1/2 of 4 and 2. This will be then 4 times the sine of 45. And we get 2.83 square units. So this will be our answer. So now this would suggest then, if you have a triangle with two given sides and the included angle, you can find the area based on what we did here. Let's close this here. And that is a true statement. We can go over here to this right here. We look at this triangle over here. We say the area of a triangle, in this case this general triangle here, is equal to 1/2 the base times the height. So doing the same thing that I just did, this is now a general one, no actual values. So you can derive an actual formula here. And say, again, like we did, we can say that the sine of A is equal to the opposite side, which in this case, the way I have it drawn is the altitude or the height over B. Solving for h here, multiplied by b, both sides by b, we get h is equal to b times the sine. Of A. So I'm getting back to over here, using the area of a triangle is equal to 1/2 the base times the height. So let's fill it in here. This is going to be 1/2. So the height here is b sine A, the base is C. So let's just put those together, CB or BC. Sine of A. So this again tells me that if I have any triangle and two sides and the included angle is given. So in this case I'm looking at B and C and I use this angle here, so the included angle is A, then the formula for the area will always be 1/2 the product of those two sides times the sine of the included angle. And we can change the orientation of this triangle that I have drawn here and start off with from this side with B and look at the sine of angle B would be h over A. We get a different perspective. And that just gives me two other formulas, and these are given here. Now just saying the same way, we can say the area of a triangle is 1/2 the product of AC times the sine of the included angle, or 1/2 AB times the sine of the included angle. You get the other formulas. Thanks for watching. We'll see you next time.